Okay folks, you're watching this video because you want to know more about conversions and how to do them the proper way using something called conversion factors. So in order to convert, we have to change one unit, that's what we're going to call this, into another one. So that means there's got to be a relationship. There has to be an established pattern here for us to use. And a lot of times those are called conversion factors, and those conversion factors are going to be found on a chart that looks very similar to this. So this is Appendix A, and it's called Metric and English Conversions and Some Physical Constants. So whenever we talk about these conversion problems here in the next video or next two videos, you're going to hear me refer to Appendix A. So have this printed, have this ready, have this convenient because we're going to be using it quite often. And we're going to first start off talking about this English to metric unit system first, because I think that's really easier to grasp. And then we can use what we learn in the English to metric conversions, and then we can use those to metric conversions, which is something that's a little more foreign territory for us. So what is an English and what's the metric unit? Well, folks, we here in the United States still use quite a bit the English unit or the English system. And basically when I say that, we measure things very often in terms of inches and feet and gallons and quarts, and we're not really measuring things in the metric system. The metric system, instead of inches, would be something like centimeters or millimeters. Instead of miles, we're looking at kilometers. Instead of yards, we're looking at meters. Instead of gallons, we're looking at liters, and so forth. So this is something that's more unfamiliar to us, or the concept of the size or the length or the quantity that we're talking about. So in Appendix A, this table is going to be uploaded for you to use. And a lot of the questions, the conversion factors that we will need to solve those questions will be found on this chart. Now, not every one of them will. Some of them might require a Google for you, or maybe looking in the back of a general chemistry text if you have one laying around somewhere from another course. But Appendix A is going to have quite a few of them that we need. So I would say go ahead and print this off. You'll need it. You'll need to use it often. So might as well take that sheet of paper, print it, and then tape it into your notebook so that way you've got a very quick reference of this whenever you need it. Appendix A is going to be divided up into a couple of different categories. The first one's going to be length, and this is of course all of the lengths that you would measure maybe with something like a ruler, or volume in terms of how much space a liquid takes up, or mass. So here we're finding things like kilogram and gram and pounds and ounces and so forth, and tons. So all of these, again, we're kind of dancing between the English and the metric units or the system. Over here to the right-hand side, these are physical constants that you'll see here. Some of these we've already used, some of these we will use. So again, a great reference for when you need it. And then here over to the right-hand side, you'll also see a category for pressure that relates the two to each other, such as pressures per square inch, PSI to atmospheres, as well as the category of energy. And energy bounces back and forth between calories and joules for the most part. Finally, here at the bottom, which is how we'll end, maybe not this particular video, but the one after this one, will be temperature, and this is relating the different temperature scales. So whether you're in Fahrenheit or in Celsius or in Kelvin. So this table is going to be pretty important. We're going to use it quite a bit. So again, save it, have it as a quick reference, print it off, tape it in a notebook. You know, if you're here on campus for other courses that you're taking from us, at least shove it in there too, because you might find yourself needing it for a laboratory course or in one of our other classes as well. So now we need to just kind of jump into this whole idea of, you know, why is this needed and what is its purpose and how do we do it? So conversion factors are going to be pretty important because, again, in the United States, we really don't use the units that the rest of the world uses. So we're going to have to get into the proper units for the question, or the proper units for the measurement that we need to make. Or if we're reading scientific literature and we're looking at units that we're very unfamiliar with because we're not trained in the metric system, how can we kind of imagine how much mass or how much volume or what is the length of this particular object that we have in question? So in order to do conversion factors, it's pretty simple. It's a little bit of basic math, and there is a template that we will use every single time that conversions come into the picture. And I take what we call the given number, and I always put the given number over 1. And this sets the dimensional analysis problem up. And then in the next step, whatever unit is up here on the top, that unit needs to go here at the bottom every single time. And then up here on top is the unit that we actually want. Okay, so this is the general setup. Now, sometimes it might take one step and we'll get the answer, and one conversion factor is all that we'll need. But sometimes we have to do 2 or 3 steps, and that's okay because it's going to be the same unit. I'll just keep chaining on this conversion factor, one after another, until we get to the unit that we actually want here, because sometimes it's not just a direct connection. And we'll see that in the conversion factor table. So in other words, what I'm saying is that here meters and inches are together. But the problem is, what if the question goes beyond that? What if we want to go further than inches, or if we want to go further than meter? How can we do that? Well, that direct conversion factor is not on this chart, but we can take it in multiple steps as long as we connect the proper pieces together. So sometimes these dimensional analysis problems will be more than one step. All right, so how do we do this? Again, folks, I think that it's always best just to jump right in and kind of show you what we're getting ready to do here. So 55 miles equals how many kilometers? So the question's going to ask me, convert, right? Use this unit of mile and convert that into a kilometer, because we use mile, but the rest of the world uses kilometer. So we need out of that unit into something that we're very familiar with, and we need into a kilometer that we might not be very familiar with at all. So in order to do this, I need a conversion factor, right? I need to figure out, well, what is the relationship between mile and kilometer? Do we have that? And the answer is yeah, we do, because here's Appendix A, and I need mile and kilometer. That sounds like a length to me, right? So here I see 1 mile equals 1.609 kilometers. There is a conversion factor that's right there. It says 1 mile is 5,280 feet, or 1 mile is also equal to 1.609 kilometers. So that's probably the conversion factor, and I'm going to just jot that down over here to the side, right? So 1 mile equals 1.609 kilometers. That is what came from that conversion chart. So there's going to be a chance that I'm going to get a little bit lazy. I won't flip to that chart every time, but I think that you can find those conversion factors on that chart when I reference to them, and I'll write down the proper conversion factor that we're using over on the right-hand side whenever we do these problems. All right, so I need to set this dimensional analysis problem up the proper way. I need to show the work. I need to show the step-by-steps on how to get there. So in order to do that, I'm going to take 55, and that's 55 miles, and I set that over 1 every single time. That's how I start my dimensional analysis problem up. Right? Then I bring in what we call the conversion factor. So what does the conversion factor do? It helps me convert that unit into something that I want. I hope, with my fingers crossed, right? So mile on top, and mile needs to go onto the bottom. And the conversion factor that we want here is kilometer. So kilometer will go onto the top of that dimensional analysis problem. Notice what I've done here. I didn't really worry about the numbers. I didn't worry about the concrete values. I've really only focused on the unit first. If I don't put the unit up the proper way, then the numbers don't mean anything, right? If I can't set the problem up properly, whatever number that I pull from, and I can get the right numbers over here on this conversion factor, but if I can't set the problem up the right way, then I'm going to get the wrong answer every single time that I use these numbers. So that's why I always tell you, worry about the unit first. So mile on top, mile goes to on the bottom, and where we want to end up with is kilometer, so kilometers on top. So what we do here is that allows the miles to actually cancel. All right, so let me kind of take this back in. So here we have mile and there we have mile. They cancel. And now the unit that I have left is a kilometer. And that's exactly the unit that we need. So in order for me to figure out what I need to do here as far as the math goes to the problem, I need to look at the conversion factor. The conversion factor says 1 mile. All right, so that means in this conversion factor, mile is right here on the bottom of that dimensional analysis step. And there is a 1 that's in front in that conversion factor. So there's mile, and a 1 needs to go in front of the mile there as well. And then it says that's equal to 1.609 kilometers. So there is the kilometer unit that I have in the math problem. And in front of that kilometer, there is a 1.609. So that means 1.609 has to go there in the dimensional analysis as well. So when I begin to look at this math step now, what it looks to me is that I'll take 55 divided by 1, and then I'll multiply that by 1.609 divided by 1. Well, let's simplify this down. 1 times 1 is going to be 1 no matter what you do with it. And anytime I take a number divided by 1, I'm going to keep that number anyway. So a lot of times in these dimensional analysis problems, I just ignore the ones or even there. So what this tells me to do is take 55.0 and I multiply by 1.609. So when I take 55.0 and I multiply by 1.609, what I'll get in my calculator is an 88.495. All right. Now let's take a look at the number of significant figures, because you know what those are now, right? So the number of significant figures here, 55.0, there are 3 significant figures in that value, which means that my final answer needs to have 3 significant figures as well. So 8 is my first one, 8 is my second, 4 is going to be the third. So that's the spot that I need to round. The 9 will round that 4 up to a 5. So my final answer here is 88.5 kilometers. So that is how we do dimensional analysis. That is how we do a straight up conversion factor problem using the Appendix A table that you will always have. All right. So this is a one-stepper. It looks pretty easy. And a lot of the ones that we're going to see in the very beginning are going to be one-steppers at least. If not, then they go to 2, they go to 3. You're going to be able to find them in that table. So let's do another one. Let's do 1.25 meters equals how many inches? All right, so it looks to me I'm going to have to come up with a conversion factor. And I need to convert meter into something that we more comfortably know as an inch in the United States. So how can we do this? What kind of factors do we need to bring in? How can we convert that one unit to the other? So I need Appendix A, and I need to look for meter, and I need to look for inch, right? So let me get rid of a lot of these scribbles, and it looks like I'm going to be up here in the length category. So it looks like I have meter and inches, and here I see 1 meter, and that's equal to 39.37 inches. So there is a direct conversion here, and that makes me happy because that means that this is just going to be a one-stepper. So 1 meter equals 39.37 inches. All right, so 1 meter equals 39.37 inches. That comes straight from the chart. So now I need to figure out how do I properly do the math, and dimensional analysis is going to tell you that. So I'm going to take 1.25 meter and I put it over 1 because that's the way that I set up these dimensional analysis problems every single time. And then in the next step, I only worry about the units first. So meter on top, therefore meter goes on the bottom, and I need to go to the unit that I want, and that unit is going to be an inch. So yes, I do have a direct connection. A meter can be converted to an inch in one step, so inch will go up here on the top of that dimensional analysis fraction. Now I worry about the numbers, right? Now that my units are there, I worry about the numbers. So 1 meter, there's the meter, there's a 1 out in front, here's the meter, so there's a 1 that's going to go there. Okay, the inches, I have 39.37. There's the inch unit, so 39.37 stays with it. You never break those up. They stay together. That's the purpose of the conversion factor. So now if I forget about all of the ones, the meters will cancel. That's good. That leaves me with inches as far as the unit goes. And I'm going to take 1.25 and I'm going to multiply by 39.37. So when I do that, I'm going to get on my calculator a 49.2125. And it looks like in the original problem, there's my number. There's 3 significant figures. So I want 3 significant figures in my answer. And 4, a 9, and a 2, that will be my 3rd digit. So I need to look to see what I need to do with the 2. So there's a 1 after it. It does not round up. So my answer here is 49.2 inches. That's going to be the answer to that problem. All right. Okay, well, let's do another one. I mean, hopefully you see that these aren't too bad as long as you have the appendix in front of you. As long as you know the conversion factor, then you should be okay. So 150 milliliters is equal to how many fluid ounces? All right, so I need that appendix A, and I need to look for mil and fluid ounce. So this sounds like it's going to be in the volume category, and it is. It's down here in that section. Milliliters and fluid ounces. All right, so I see liter, nothing here in the top one. And then here I see gallon, quart, pint, liter. And then here I see quart and fluid ounce, quart and liter, quart and milliliter. And then here I see fluid ounce and milliliter. So it might look like that's probably what we need, right? The question said 150 milliliters is equal to how many fluid ounces. So this is a direct relationship right there between those two units. That's the conversion factor that I'll need to use for the problem. So 1 fluid ounce equals 29.6 milliliters. All right, so 1 fluid ounce equals 29.6 milliliters. That is what that Appendix A just said, right? There we go. 1 fluid ounce is 29.6 mils. All right, so that means when I solve this problem, I'm going to take my 150 milliliters and I put it over 1. And then in the next step of the dimensional analysis, don't worry about numbers, worry about your units. So milliliter on top, milliliter goes on the bottom. Can we get to the unit that we want? And the answer is yes, because we just pulled that conversion factor from that table. So we can go to fluid ounces. And I don't know why this is doing that. All right, so we can go to fluid ounces without a problem. All right, so now I've got to figure out where my numbers go. There's a fluid ounce with a 1 in front. There's my fluid ounce, so a 1 goes there. And then here's 29.6 mils. There's the milliliter unit, so a 29.6 is going to go there. So in order for me to solve this problem, I need to take 150 times 1, which is 150, and then I'll take 1 times 29.6, which is 29.6. Or if I just completely ignore the ones, it looks like I take 150 divided by 29.6. And that's exactly what that math function is going to tell me to do, no matter how I look at it. So 150 divided by 29.6, it gives me quite a long decimal value, 5.06767 fluid ounces. So this 150 decimal, that means the first non-zero gets counted. So 1, 2, 3, all 3 of those count, 3 significant figures. So the 5, the 0, the 6, there's my 3rd sig fig. It rounds up, and it rounds up to 5.07 fluid ounces. All right, so there is another conversion factor done and taken care of. So our next problem is going to try to trick us, but please don't let it trick you. I want you to pay attention to the units and figure out what they're trying to do with them. So here I've got a 55 mile per hour, and they want to know what is that in kilometer per hour. All right, so they're trying to throw us for a curveball here because they're doing the per hour. And here, what's kind of nice is that the units are the same on both sides of the equation. So in the dimensional analysis problem, I can actually keep that unit. I don't need to get rid of it. Remember we kept putting it over 1? Same thing can happen here. We'll just put the hour down there at the bottom. All right. So I don't need to do anything with the hour unit. The hour is here and the hour is there. It's the same. I don't need to mess with it, so just keep it. What I need to convert is my mile to kilometer. So I need to come over to the side and I need to figure out what kind of conversion unit I'm going to have to use. Can I relate a mile to a kilometer? And the answer is, of course we can. We kind of already done this. Here is the mile, and that is a 1.609 kilometer. So nothing more complicated than what we've already done, except they just try to trick us by throwing in that per mile. So what? We don't have to do anything with it. It's not that more complicated. So 1 mile equals 1.609 kilometer. So 1 mile equals 1.609 kilometers. So mile on top, mile goes on the bottom. The unit that I need to go to is a kilometer. I can do that in one step because I've figured out a conversion that connects the two directly together. So mile has a 1 in front. There's my mile. A 1 goes there. A kilometer has 1.609 in front. So a kilometer has 1.609 front there. To solve for this, my miles cancel. Kilometers left on top. Hour is left on bottom. Didn't do anything with it. It stayed on the bottom. It's still on the bottom. That's exactly what that problem needs. So I'm going to take 55 and I'm going to multiply by 1.609. And I get 88.495. That's 3 sig figs. I round it to 3. 88.5 kilometers per hour. All right, next one. Example problem, example problem, example problem. I've got 4 liters, and I want to know how many quarts is that. So liter and quarts are in terms of volume, and it looks like we do have a relationship that we can use to connect the two together. Here's quart, and it says 1 quart's 32 fluid ounces, or 1 quart is also 0.946 liters, and that's exactly what we want to use. That's what we need for the problem. So 1 quart is 0.946 liters. All right, so 1 quart is 0.946 liters. So to solve this conversion problem, I do it the same. I'll take 4 liter over 1, bring in the conversion step, liter on top, liter on the bottom. I need to get to quarts. I've already figured out I can do that directly in one step. I don't need anything else. There's a quart. There's a 1 in front. Here's a quart, so there should be a 1 in front. There's a liter, 0.946 in front. There's my liter, so 0.946 is going to go there. All right, so to solve this problem, my liters cancel. I'm left with the unit of quart, which is what I want. And I'm going to take 4, and I'm going to divide that by 0.946. And then I hit enter, and I'll get another decimal, 4.2283, blah, blah, blah. I've got 3 significant figures here. The number has a decimal. The first non-zero counts. Everything else afterward also counts. So there's 3 there. So 4, there's my second, there's my third. This is where I need to round. So 4.23 quarts will be the answer to that problem. All right. So there's a couple of example problems that I would say are one-steppers. And these one-steppers are really where we like to start. And it's converting this English unit into a metric unit or vice versa. These are just straight up, here's the number, here's the units, this is what you want. But you can also get some fancy word problems too. Don't let those trick you, because the word problems are still going to have in them a number with a unit, and they want you to convert that into another number with a unit. So we'll see some of these, but do not think that they're any more complicated. It's just a lot of words that you have to ignore, and we're just focused on the number and the unit. So in the next video, we'll talk about more on conversions, and we'll get into the metric to metric conversions as well.